we start the meeting, sir.
Good morning, one and all present here. We have to pray with our eyes on God, not on the difficulties. I request student of computer science to sing a prayer song.
Guru Brahma, Guru Vishnu, Guru Devo, Maheshwaraga, Guru Saksha, Parabrahma, Tasmai Shri Guruve Namaha.
I request KST Ponmagi, student of Computer Science, to deliver the welcome address.
Good morning, everyone present here. I am very happy to welcome you all. First of all, I welcome our chief guest, Mr. Hari Praveen, Solution Architect, Acrio India Private Limited, Chennai, for this wonderful occasion. Welcome, sir. Next, I welcome our college principal and SF coordinator for this session. Welcome, sir, and welcome, ma'am. Then, I welcome our department HOD, ma'am, faculty members, participants, and my students and friends. Once again, I welcome you all. Have a nice day to all.
Now I welcome Mrs. T. Jyoti ma'am, Assistant Professor of Computer Science, to introduce our chief guest.
Good morning, one and all present here. It's my privilege to introduce our honorable chief guest of the day, Mr. Hari Praveen. He holds a bachelor degree in electrical and electronics from Anna University. He has been with Acrio as a solution architect since 2022. He is leading a team of engineers and interns in Acrio India office in Chennai. His areas of interest include machine learning, data visualization, NLP, cloud solution, and IoT. He was actively involved in technology projects executed at RRC for Acrio USA. Welcome, sir. Have a nice day, sir. Thank you.
Thank you, ma'am. I invite our honorable chief guest, Mr. Hari Praveen, sir, to take this section. Over to you, sir.
Hey, RRC. Before we start the presentation, I just want to say a few things. During this particular presentation, please feel free to ask any questions. Either you can use the chat option in your Gmeet, or you can very well notify me and pass me so that you can raise your questions. Is that fine?
Hari, we will have a question session after the presentation, Hari. So,
Yeah, that's also not an issue. I'm just
yes,
asking if
yes,
someone
sir.
is need more clarification. Please feel free to stop it so that I can clarify them on
Okay.
spot.
Okay, Hari, carry on.
Okay. So today's session is about digital twins for industrial IoT. So in this particular presentation, we'll be covering about what digital twin is, what role does a digital twin play in today's industry, and what are industrial IoT is all about, and what are the challenges and the benefits of implementing the same. A small use case, and we'll also be saying how we would implement it and what are all the areas in which this digital twin can be used. And also be talking a bit about MQTT and what is the future of this particular technology, or how this technology will be used in the future of other technologies. And then finally, we'll also have a separate Q&A session. Okay. Moving on to digital twins. So what is digital twin? From the name, we can say that it has the words digital and twin. Twin means it's an exact replica. Okay, that's what we heard about twins. So when two persons are look alike, we call them as twins. And if two product or two machines are the same, we can call them as twins. But when we call it as digital twins, then what is the difference is when we say an object exists in the physical realm. When I say physical realm, you can see it, you can touch it, you can feel it, and it exists on the real world. But when I say digital world, it's all about the data. How we can represent a physical object in the digital world. So, for example, if I say table, a table can be represented as an object in terms of a code, or a human can also be represented by a object in terms of a code. So let's take like an ID card for an example. Your ID card represents your name, your gender, your area of expertise, or your role, and what are the things that you do, and your bio informations like your blood group and other things. So these are the basic set of information that is available in your ID card. Okay. And so this is your physical ID card. So when I go for the same for the digital ID card, it will also have all these information in a separate way, like in a maybe an Excel sheet or other programs, in a way that it is stored in the data format. So now we are talking about data in the digital world, but still we don't have the concept called as twin, because whatever I do to this ID card does not happen to this ID card. Same goes for things like action. So if there is a robot which has some set of action, like this mechanical arm, where it can take an object and place it at some spot. So whenever I change the digital object or the physical object, each object does not change. If I So to have this particular effect work, we need something called as a mirroring concept. Mirroring is nothing but it's a common concept we use in mirrors. So whenever we look at a mirror, whatever we do is replicated inside the mirror. So in our reflection, whenever we do something, the same thing is happening in the mirror. So similarly, the mirroring of physical assets is happening inside the digital twin as well. So whatever a physical asset does, the same thing the digital asset should also do. You get it? So for example, if I'm swiping my ID card at your college entrance, or if I'm marking my attendance in a classroom, or if I'm using my identity anywhere in your college, so this records will automatically get registered both in a physical attendance register as well as a digital attendance register directly. So this is where your digital twin comes in. So only if you have this mirroring aspect into it, it becomes a digital twin. So a good example of a digital twin would be, let's say like you have a smart home. In smart home, you can control everything using your cell phone itself. Like you can turn on your air conditioner, turn off your air conditioner, turn on your washing machine, television, play a song in your speaker, or control the lights and the temperature, control gates, everything using your smartphone by itself. So your smartphone handles the digital aspect of all these devices, whereas your physical devices would be your gate, air conditioner, washing machine, your temperature control system, or whatever it is. So the software that deals with this particular aspect creates something called as digital twin. So that whenever something happens in your digital layer, the same thing happens in your physical layer. So if I turn off my AC, my air conditioner would be switched off. Okay. So everyone, hope everyone is clear till now. So how this concept started? So the origin and where this concept started was from the aerospace industry. So aerospace industry involves flights and aircrafts in general. So they have something called as a turbine, and they have a jet engine which house this turbine. So all these things has to be precisely installed in a correct way so that an aircraft will have a lift off and a safe travel. And even in this safe travel, there are several hurdles like storm, lightning, which would affect the flow of the aircraft. Okay, so the aircraft industry wanted to have a implementation where they don't want to drive a real aircraft into a storm and check it. So they created a simulated environment where it could mimic all the storm scenario, all the landing issues and the takeoff issues. And they created an aircraft as similar to the physical aircraft as possible in the software. Okay, so when they add these scenarios, they would be able to test how faulty the turbine is, what could be better implemented on the structural design of the aircraft, or how it should work during turbulence. So all these things they were able to do just based on this particular piece of software. So later, this particular software became the digital twin, or gave rise to the concept of digital twin, because a lot more other industry wanted it, because this saved a lot more things. For example, in an industry, let's take like we are looking at a car engine manufacturing power plant or a plant. In this, a digital twin would improve the real-time monitoring. So for example, I have a sensor on all my manufacturing unit, and I'm able to monitor all these sensors from a remote location and I'm able to control them. Then the things that would be possible for me are to monitor every instrument that is being made, how precise it is. If there is anything that is going wrong, I'll immediately get a notification that no, this part is not functioning correctly, so that it will be moved immediately out of the assembly line. Okay, so this is enhancing your real-time monitoring. So normally what we have in most industries are real-time monitoring, where you can see whether the value is correct or not, whether the temperature is correct or not, whether the pressure is correct or not, whether the part is aligned perfectly or not. But enhancing the real-time monitoring gives you the facilities of adding other features like artificial intelligence and some cases like predicting what issues that are occurring directly. So for example, if a part is misaligned, the notification should be sent immediately to the supervisor. We should not say that a part is disaligned and move throughout the conveyor belt. Should immediately trigger to the supervisor, and you should also stop the machine. So that is enhancing real-time monitoring. So that monitoring is no more just looking at it, but it's also, it should say that this is an issue. This is a critical issue. The plant has to be stopped. There's supposed to be a fire here. So this is where enhancing real-time monitoring comes. So in terms of predictive maintenance, everyone has seen the check engine light on cars. In cars, normally when you drive, there's a small engine-like icon that says that you need to change your engine oil, or you need to check your engine. There's something wrong is happening in the engine. So take your time, fix it. So this is what your change engine yellow light is supposed to represent. So this is nothing but a way of predictive maintenance that the car follows. So in an industry, a predictive maintenance would be like, this sensor is supposed to be replaced. Your battery will be out in the next 40-50 minutes. This product is almost out of warranty. You need to change it. And you need to switch off the system and let it cool off for some time. So all these things are predictive maintenance that you can suggest the industry based on the data that you collect from all these sensors. Okay, improving product design. So when I say product design, Let's take for the aircraft as an example. Using simulation, people will be able to better design how an aircraft should be, how it should be built for turbulence, for better landing, or better capacity, etc. In terms of reducing downtime, always we need maintenance, and whenever we have monitor something, we need to turn down the software at one point of time. So using all these sensors, and we'll be able to get how the production is working. So when it is peak load and when there is a minimal load, so we'll be able to suggest the best time to turn down the industry so that all these maintenance can happen. Optimizing processes is something like how we'll have a continuous assembly line so that the industry can work seamlessly and continuously. A good example of this would be like how car industry works. In car industry, there's a assembly line where they used to manufacture each part by part, and each labor would be assembling one particular equipment, and then finally the car gets fully built. Now most of these process is automated. For example, if you take Tesla into count, or if you take Hyundai, almost like the entire assembly line is fully automated by using robots and sensors. So they are using technology that are similar to digital twin, that are solving most of their needs. Now talk about why should the industry have it. So when you implement a digital twin across a sector, be it any sector, it increases the efficiency because you're automating it. Okay, so this would increase how you perform, how the industry performs, the output of it. Okay, then the next is you will be reducing things like labor cost, because if you're automating it, there's not going to be any person who's working on the task, and you're also going to get better electric efficiency. So that is also again going to reduce your cost, and you're by increasing your efficiency, there's a direct reduction in cost as well. So it also gets reduced, and you'll be able to make better decisions based on the sensors data. Okay, this let's take like we are implementing digital twins in agriculture. I'll be knowing the temperature of the soil. I'll be knowing the humidity of the air. I'll be knowing the humidity of the soil. And now I'll be knowing what is the temperature the plant has to be. So if I'm having a crop, I know when to give it water, how much water should I spray to the land. Okay, so by knowing all these, I'll be able to collect information of weather patterns and other things so that I can better plan and better make decision to have a successful harvest for my agricultural land. So this is where a digital twin can come in agriculture, as well as this is where decision making process could be made using a lot of sensors. So imagine like you're in your town, in your home, where you're just seeing your agricultural land in just a tablet, and you're checking the temperature, pressure, humidity, everything, and you're saying that, okay, water is there in the soil today, fine. Then again, you're checking it and you're saying that, okay, the land is ready for harvest, we should harvest it. Or else if you see any pest or other damages in the crop, again, the machine learning model can analyze you and say that this is the damage is there in your crop. You can use these chemicals to just fix it. All these things can be integrated into the software so that when you see the replica of your land, that is your digital twin of your land, you'll be able to get all this information in your screen in a click of a button. Okay. And by doing all these things, by doing simulations, other things, you improve the product quality of your end product, be it the manufacturing industry or any industry. Your end product's quality would be improved because you are continuously monitoring the system for faults, and you are also eliminating the not present inside your output. So it always be a fine product that you get in your resulting system. So these are the benefits of it. But the challenges were also immense earlier. So most of these challenges are not present now, but earlier these were many. So one is data security. So now we are letting one particular sensor and controller to control your entire office or entire industry. Then if any other person is able to get control of it, they'll get all the information from it. They'll be able to control the entire industry with it. So data security and privacy are the main concern. But having the latest encryption technologies and technologies like blockchain and other things, this data security and privacy can be better protected in the industry level itself for now. Integrating sensors are a very complex part because each sensor is manufactured by one organization. If I have temperature sensor, it has one particular formula. If I have pressure sensor, it has another formula. If I get temperature sensor from one manufacturer, they'll give me one set of code. If I get it from a different manufacturer, they'll give me a different set of formula. So having all these integrated into one particular entity is tough when you go for large sensors. Like let's say like one industry requires 5,000 sensors to be integrated. Then integrating all these 5,000